Well, hello and welcome to the radio room. Got a little bit different type of video we're going to do today. Um, we're taking a look at a night VFO. This is a rather old external VFO. To just kind of give you an idea, you might be kind of wondering what in the heck you need an external VFO for. Well, this dates back to probably 1955, 1960s, very early 60s. In that day and time, a lot of amateur radio transmitters were crystal controlled. So whatever crystal you put into it is the frequency you're locked on, unless you pulled out the crystal and put a new crystal in. And some of the transmitters, that crystal was very easy to get to. It literally just plugged into the front of the transmitter. And particularly back in the 1950s and 1960s, if you had a novice class license, you were restricted to a crystal controlled radio. You cannot just spin the dial, so to speak, and transmit, wherever on the band. You had, of course, your portion of the allocation of whatever band that you had that was for novice privileges. But you had to have a crystal controlled radio. And novices, if I'm remembering correctly, I believe only could have a novice license for a year, if I think correctly, or it was only good for a year. And then you were encouraged after that year to upgrade to a general class license. At which point, you weren't rock bound, as they were called it, and still kind of do call it now. So you could go from just having to operate on these crystal controlled frequencies, one specific frequency, unless you change the crystal, to being able to transmit anywhere within the amateur radio bands that your general class license gave you privileges for. So just imagine yourself as a novice back in the late 1950s, early 1960s. You couldn't have a radio with a VFO as your transmitter. It had to be crystal controlled. I suppose it could have a VFO in it, but you couldn't operate off the VFO. So, say you had a crystal that would let you transmit at 3.510 megahertz. You put your crystal in and you tuned your receiver to the same frequency, and you started calling CQ. And you hope somebody found you, was tuning around and found you, and then they would move their frequency to there, and y'all had your contact, your conversation back and forth. But if you were tuning out around on your receiver, and say you only had, say, 5 crystals for the 80 meter band, and maybe you didn't even have that many, you're tuning around and you find somebody calling CQ, which means they want to talk to somebody, and they're on a frequency that you did not have a crystal for. You did not make that contact. When you moved up to general, you could have a VFO. You could spin the knob, so to speak. So anywhere in the band that you wanted to go, if it was 1 megahertz or 100 kilohertz up from where you had your crystal, you could just move a VFO, retune your radio to that frequency, and you were good to go. Well, a lot of those novices, when they first got their license, for one, because of cost, possibly, and two, because the rules said that you had to operate crystal controlled, their radio would only operate as crystal controlled. It didn't have a VFO in it, or their transmitter. You got to remember, back in the 1950s, 1960s, most operators were still operating with separate transmitters and receivers. And there were schemes in which you could make it so that one tracked and tuned directly with the other one. But in a lot of times, your transmitter, you tuned separately from your receiver. So this novice now has this crystal controlled radio. He's upgraded to general. He's excited. But he doesn't want to buy a whole new transmitter or build a whole new transmitter that has a VFO in it. It would be easier if he could just take his existing transmitter and put a VFO either in it, or you would buy an external VFO that hooked up to it that could control that frequency of that radio, much like the Crystal did, but without being locked onto that one specific frequency. So that's what this was basically designed for. You could take this and you basically, in a lot of ways, just plugged it nearly straight into where the Crystal was. I would assume there would probably be some little adapter or something. So this would be doing, call it a variable crystal. As you could tune this, it would change the output frequency from this, and that crystal was controlling the oscillator and the transmitter. So as far as the transmitter was concerned, you had its crystal input was variable. This was a whole lot easier and a whole lot more affordable than building or buying a whole new transmitter. The transmitter was fine. There was just no way to continually change the frequency of it. So they sold these. And this came as a kit. When you bought it, all the parts were in the little baggies or boxes, little, probably more than likely paper envelopes back then. I don't think they were using little plastic baggies back in 1955 too often. I'm not even sure Ziploc was around then. So when you ordered it, it was not assembled, which kept down on the cost. You weren't basically paying for somebody else to build it in a factory and then send it out. Because you got to remember, back in the 1950s, a lot of electronics was still handmade, so to speak. The boards might have been printed out, if there was boards in a piece of electronics. A lot of it was point-to-point wiring. There would be sockets or terminal strips in there that things would connect to. Capacitors and resistors and stuff would be mounted either on like tube sockets, on the legs of the tube sockets, or onto terminal strips. And so you just had point-to-point wiring, and a lot of that had to be done by hand. Somebody literally had to go in there, and they probably had, pre-cut lengths of wire. All the parts they needed were there. They just had to basically solder it all together. So the cost of manufacturing something or putting something together had a little bit more of it wasn't done in 5 seconds, going down an assembly line by some sort of computer controlled or a mechanized process. It would go down the assembly line, and the first person might put the tube sockets into the board or into the chassis, and the next person might go in there and wire say all the resistors onto the tube sockets. I'm just using examples here. And the next person might run the wiring between one section and another section and loom it. So there was a process to it. So you could save a lot of money in buying kits. And in my opinion, a kit is probably, especially when you're newer into electronics and into ham radio back in the 1950s and 1960s, was probably a pretty good deal. For one, lower cost, and two, you actually got in there and you honed your skills. So you find those kits now that have been assembled, and this one was a kit. I don't know how experienced the person was that put it together. They might have been very experienced, or they might have been very much a beginner. And in that case, sometimes you get into some old kits and you look at it and you're like, what was this person using as a soldering iron? Were they just heating up the end of a paper clip and hoping for the best? Did they using too big of a soldering gun or something and trying to solder in tiny, small resistors and stuff? So you never know what you're going to get into on that. But this came as a kit. It was put together and then hooked up to the transmitter, and it gave you a VFO. a lot easier to upgrade a transmitter to having VFO capability than either rebuilding it or maybe having to do quite a bit of circuit and layout changes to build a VFO into a transmitter. So this VFO right here, it's night. I did do a little bit of research on this. It does not, that I can tell, have a model number literally written anywhere on the VFO itself, unless I'm just not seeing it, and I don't see it. But it appears that it was a V44 night VFO V44, which was, I believe, manufactured by Allied Radio, Allied National, something like that. This one was given to me by one of my ham radio friends. That he had it for quite a while, and I believe it was his father's. So it's probably dating back to 1955, 1960, and he had gotten it. It sat on a shelf and whatnot. My friend's got modern equipment. I literally cannot think of anything that you buy now that you would have to have an external VFO for. And he knew I liked older stuff, older electronics, and kind of getting in there and playing with them and looking at them and whatnot. And honestly, I don't know if there's anything I'll ever do with this VFO, but I find it interesting, and it's a piece of, one small piece of amateur radio history from, wow, 70 years ago now, nearly. So I figured we'd just kind of take a look at it. It's a little dirty, a little dusty. I need to clean it up some, but it's literally, I pulled it out of the box that it came over here in, and I figured we'd kind of pop it open, take a look. There's no real goal to this video. Just want to kind of bring it to you, and we're going to pop this thing open, take a look on the inside. If things look somewhat safe enough, we might plug it in and see if it turns on. Maybe hook up the oscope to it. See if it does put out some signals, at least a frequency. And the reason I'm saying we might, it depends on what we find on the inside. If this thing was, if everything in it is original from even 1960, we're looking at 64 years, and there's one pretty good size. I think it's a 40 microfarad electrolytic capacitor in there that's I think 450 volt rated according to the schematic I looked at. It may or may not be good. It might short out. I don't know. If we do fire this thing up, it's definitely going to be on the dim bulb tester. And we might put the variac in line and just bring the voltage up nice and slowly on it. That cap might reform a little bit if we bring it up slow enough. If I do that, I'll probably just pause the video and bring it up a little bit, but we'll hook it up initially. So this video might turn out to be short if things don't either look very good, or if the dim bulb doesn't light so dimly when we hook it up. But I just want to get in there and take a look, kind of see what's going on inside this thing, kind of find out how everything looks inside. So just to kind of go over the VFO here. First off, this VFO has an internal power supply that powers it. You could get a VFO, external ones back in that era, where you run voltage either coming out of the transmitter you're using, or to have an external power supply that would power it. This one has it built in. And that one capacitor I was talking about is actually part of the power supply circuit on this. It does have tubes in it. It's got a rectifier tube, a regulator tube. It's got a oscillator tube and a buffer tube. So 4 tubes: rectifier, regulator, oscillator, and buffer. The first 2 basically make the next 2 work. Rectifier turns the AC into DC. The regulator maintains the voltage at a very specific voltage. I believe it's 150 volts on this one. A 082 A3 tube, I believe it is. I believe it's 150 volts is what it's regulating it at. And I'm really kind of hoping we can turn this thing on. That regulator tube, most tubes don't just really glow, but those regulator tubes had a nice violet color to them, so I kind of want to see that. I think that'd be kind of cool. So we'll see how that works. Kind of depends on that capacitor. There's really not a lot inside this thing that can go wrong. Most of the capacitors in there are actually variable capacitors. There's some inductors, obviously the tubes, and some resistors. And the resistors may have went out of value. We'll have to take a look at them maybe. But we're not really going to do anything with this thing. We're just going to open it up, see what it looks like on the inside, and maybe turn it on. And that might be the end of the video on just trying to turn it on. But let's go over it real quick. So you do have the tuning knob, and it's got a reduction gear in there. You can see I'm turning the knob faster than the dial's moving. And that's how you'd select your frequency. This one has, well, it kind of depends on which way you look at it. You have two different scales here. Right in here, you'll see there's an 11 here, 11 and 11. This was actually manufactured back before 11 meters was the CB band, the Citizens band. So 11 meters was still an amateur radio band at that time. So it includes 11 meters. And that would be 27 megahertz, looks like up through 27.3 megahertz. So basically, like, most of the CB band really. So it includes that. So, and we also have, if you go from here over on this outer scale, that's the 80 meter band. So like right there's about 3.7 megahertz, 3.8. You also had 40, 20, 15, and 10, and depending on which scale you're using is how you selected your frequency. Basically, these are tuning either capacitors or inductors in or out of the circuit. This one also operates as the power switch. So right now it's in the off position. Then you'd be in 80. You just had 80 over here. If you want to go at 11 meters, you actually went there and here. So see 11 and 11. So if we wanted to run 80 meters, we'd stay right here. We use the outer band. If we wanted to go to 40, you just go to here, move that one to there, and you can run 40, 20, 15, and 10. Now, you're probably kind of wondering, well, how do you select which one of these you're using? You don't. This thing runs on harmonics. Basically, when you're in 40, this switch position here, this is going to be operating on, well, let me just move this. So right there I'm about 7.15 on the 40 meter band. I'm also at 14.3. I'm also at 21.45. And I'm also at 28.6. And it's literally putting out all those at the same time. It was the tuning circuits in the transmitter that would pick off the right one. The filtering, input filtering from where the crystal would be going in or where you would feed your VFO in, and the band select on the transmitter would basically let the one that you want through while not passing the other ones. And that's how you would choose which band you were literally on as far as 20 or 40, 20, 15, and 10. This was basically putting out a signal for all those bands at the same time. And really the only, and even in 80 it's still doing some harmonics. It's just it's tuned better for 80 in that position, because it does also bring some other components in line with the circuit in order to make it operate on 80. So that's what these two band switches are, and once again, that is the off. Turns the whole unit off. We do have an indicator light right here, which basically tells you that it's on. This switch right here in the middle is just standby. So basically, once you've turned it on and you're in standby, the filament voltages are running. It's warming the tubes up once they're fully warmed up, and once you've kind of let this thing warm up a little bit too. It does have a power supply in it, which is a good and a bad thing. It's good because it's going to warm this whole thing up some. So you're gonna the whole VFO is not going to be as temperature sensitive to room temperature. So you come in here, it's 4 o'clock in the morning, and you start operating, and you're just having a heck of a Saturday. You're still out there at 1 o'clock in the afternoon. Well, the room might have warmed up. This thing's probably going to drift a little bit just because that temperature difference is going to change the capacitors, the air variable capacitors in there are going to change geometry just slightly, which is going to change the tuning. So if the power supply heating up the box might actually keep it more stable. On the other hand, it is warming everything up, so until it reaches its max temperature, you're going to probably have a little bit of variation. One nice thing about this that I looked at when I seen in the manual is that of this whole unit, the top part is the power supply. So any heat, and there is some venting on the back, and I'll show you that here in just a moment. Any heat from the power supply is going to rise. So it's not going to get to the actual circuitry at the bottom of the box as much. You know, if it was flipped around the other way, you'd just be baking your circuitry, and the thing would be all over the place. So yeah, you do have to wait for this thing to warm up. Not only the tubes, but the power supply to get this kind of at the temperature it's going to operate, and then it's probably going to stay pretty stable at that point. So that's what standby is. It's basically just keeping the filaments lit. Calibrate is basically you flip it to there, and it's going to, this thing's going to be putting out an oscillated frequency. And you use that in calibrate because it's forcing it on. You can make your adjustments to make sure it's on frequency. There's a couple of capacitors over here on the side, the two holes that you go to. You know, I believe on the back, and I'll show you here in just a moment, some adjustments on some inductors. And once you get it set, you're pretty much good to go. And then you go back to standby. Now when you go to transmit, it actually puts the key jack in line. You can literally put your Morse code key straight into this. And when you go to transmit, now the key is in line. Now, from the looks of the schematic, if you don't have the key in there, it's going to go to transmit. If you have the key in, it's going to wait for you to actually press the key, just because of the way the circuit breaks or makes or breaks when you're in there. When you put the key in, it actually breaks the connection, and the key has to complete it. So let's take a little look around the back side here. Like I said, this is the two inductors, tunable slugs. They're going in and out of there. Some other pictures I found online of this particular model. This is a little different. Looks like somebody's added this maybe to make it easier to tune it. Instead of just having the slug just kind of sticking out there, the screw part of the slug. You have your power cable, and it doesn't look too bad. It's a little stiff. Non-grounded plug, so we're going to be careful while we're doing this. This is your output. It goes over to your radio, and in this case it looks like they're using It almost looks like a PL259, but it's not. The jack that this would plug into screws on, and there's just a little contact in the middle that they basically mate to. I cannot remember the name of this particular connector right now. It actually has a specific name. And you could get them in multiple pins on the inside, like 2. I think they had a 3 and maybe a 4. But that's how you would connect it to the radio. So I'm not sure what radio they were actually using this on. You could use it on multiple different radios back in the day. So you also have 3 terminal connections right here, and they're basically connected to this. So when you go to transmit, you could have this wired up here to, so basically, and I'm not sure which one is which, but you know, when you go to calibrate, like, these two are connected together. And then when you go to transmit, these two are connected together. So you could use it kind of like as a remote. Instead of having to switch, like muting on your receiver, you could make it so when you hit transmit on this, it would automatically mute the receiver. Or maybe you had an antenna relay that you needed to switch. Multiple uses. Remember, when this was primary in use, you didn't have transceivers. You had separate transmitters, separate receivers. So you either literally had to flip a switch on the receiver to mute it, or you had to have some sort of remote that muted the receiver, so while you transmitted, you weren't just feeding back on yourself. Transceivers now, it's all inside. You press the key, whatever, it automatically mutes the receiver inside the radio, mostly because they both use a lot of the same circuitry. So, like I said, power cable, 2 inductors. These were for calibrating it. You adjust these to get the frequency dead on where it needed to be. And this is where you connected it to the radio. And this is just coax. There's literally RF that comes out of this. So, wanted to pause for just a moment. I'm going to see if we can't open this up. I don't think there's anything stopping us. I'll have to unwind this. Everything's got to slide out this hole. These should clear just fine. Just trying to decide here. Looks like I'm gonna have to find out whether you literally take the. I think you take the front out and everything just slides out. So it's probably going to be these 2 screws as well right here. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 screws on the front. I'm not really sure if them back 2. I think they're going to have to come out. So it looks like 12 screws. So I'm probably going to pause real quick, get a lot of these taken out, and then we'll be right back and we'll open up the... Open it up and see what it looks like on the inside. Okay, so I got the 10 screws out on the front, and then we're going to pop these last 2 out on the back. Let me get this untied. Yeah, it's been rolled up a little while. It's a little stiff. I think we're okay. I don't see it cracking as I'm undoing it, and I don't see any cracks in it. It's not so brittle it's just falling apart on me or anything, so I think we're in good shape on that. I'm going to take these 2 screws out and then see if this thing will open up. I got the 10 out on the front. Okay, so this should slide out the front. So let me get the cord over here. I'm just going to push on the terminal strips and kind of lift on the front. It's got a little bit of weight here. It feels like everything in the circuit is is all mounted to the front here, it feels like. Something's caught or wedged somewhere. Might be just our, it's actually our inductors here. Those knobs that I said that might have made it easier to put together. I'm going to just very gently see if I can do this like this. And hopefully all the cords will go through this hole and just get the case out of the way. It smells like old electronics. If anybody's ever had that smell, then they'll know what I'm talking about. Kind of a dusty smell with heat. Okay. So let's see what we got here. Oh, let me stand this back up. This came out. Was one piece. Kind of broke when I picked it up. You know, that almost looks like pencil lead. It's pencil lead. I'm not really sure what that was doing in there. Maybe he just broke off and got into there. So here's the inside. Here's the inside bottom. This is where all the business really takes place. So let's see here. We have our two tubes here. This one is BH6. And 6BH6 as well. So one of them, I guess, is going to be the oscillator tube. The other one's going to be the buffer. Just going to put these back in here. And to tell you the truth, let's take a little bit better look inside here. Flashlight. It's actually very clean in there. I do have a domino capacitor in there. Looks like a ceramic 500 volt. The soldering actually looks very nice. It's all point-to-point wiring. A reed type switch. Basically just moves those two blades to make contact. So if we do get things working, those might need, the contacts on that might need to be cleaned a little bit. You can see the variable capacitors for calibrating it right here. There's one there, and then there's one back behind it. The switches got a little corrosion on them, but they're actually not too bad. maybe need to be cleaned. Actually, really nice looking construction in the bottom of it here. Everything seems to be fairly laid out nicely. Fairly neatly. The wires, you can kind of tell, are kind of routed around things, not just a total spaghetti mess. Alright, so there's the oscillator part of it. This section up here is going to be the power supply, so we got the transformer right here. That does look to maybe be, see if I can get this so y'all can see in there. If you look right back in there, right there, it's got a pretty good size capacitor in there. I'm gonna bet that that's probably the original one. Well, it hasn't spewed its guts, but that doesn't mean it's not electrically leaky or even dried out. There's a better, you can see it a little bit better right there. Might be a little worried about that fairly high wattage ceramic, looks like wire wound maybe, resistor. Looks a little hairy. So that one might be, it might be a little bit interesting. Got our two power supply tubes up here. Let's see if we can see which one's which. So here's a 0A2. This is going to be our regulator tube. And I think it's okay. I mean, I don't see any cracks on it. Looks like the getter's at the top of this one. It's not white, so that might be a good sign that it hasn't gotten gassy. This should be our rectifier tube. Plenty dusty. 6x4 it looks like. Maybe? Yeah, 6x4. It's pretty dusty. I can just barely read it right there. I don't know if y'all can even see anything. You can almost kind of see the CX, the 6x. I think that might be a 4 right there, which I can check the schematic. I'm pretty sure that's what it's supposed to be, but that's the rectifier tube. I'm going to put it in here. If I can get the pins to line up right. And the sockets still feel good and tight. So basically this power supply is, transformer comes out, goes to the rectifier, comes out of the rectifier, goes over to, there should be a an inductor in there somewhere. And then the capacitor goes down to ground. So filtering right there, you got the capacitors to help with filtering, and then goes over to the regulator tube, which runs everything at 150. This is the one that, if everything comes on, actually has a nice pretty glow to it. A little dusty on the inside. Here's our main variable air capacitor. I'm thinking that we might tempt fate, I guess. Definitely going to use the dim bulb, and I think we'll pull it up on the Variac. And let's see if it will actually even turn on. One thing we got to be really careful on this. I need to check the schematic. I need to check to see. It's got a transformer in it, so there could be some isolation between it and the chassis, but I need to find out. There should be. I'm just what I'm going off is it's got a 2-conductor plug. You can literally plug this in either way. I just want to make sure that we're not going to have a problem with a hot chassis, but I don't think we should. It should be isolated because of the transformer. I think these literally just go to the transformer and don't connect to ground at all. Let's see if we can't take a look at the schematic real quick and see about that. But one thing I'm definitely going to do is, just from the fact when I was looking at the schematic, this electrolytic is rated at 450 volts. So I'm going to guess that somewhere in this thing, particularly coming off of the rectifier, I want to say we're probably going to have somewhere around, I think there's going to be in the neighborhood of 300 plus volts coming. Oh, there's the inductor right there. That I was looking for in there, sitting right there. I'm pretty sure that there's going to be 300 plus volts somewhere in here, probably going to some of these tubes. Just because they have that big of a capacitor in there. So it's definitely going to be, I'm not going to be sitting here and touching the air variables or anything like that. I'm going to keep my fingers out of things in here because, like right there, that could be 300 plus volts right there. So if we do turn it on, we're going to be very careful. This should be okay to touch, up here, unless there's something drastically wrong with the power supply or something shorted in there just to the case. So we'll just take some precaution on that. Let me go, I'm going to go ahead and pause again. I'm going to get the Variac out, get the dim bulb tester out, and let's plug it in and pull it up slowly. We're going to do it in standby to begin with and see if the pretty little light lights. So give me just a few moments. Alright, so we're back. Before we turn this on, I did say we were going to go look at the schematic real quick. So let me move over to it and we will take a look at this. One thing I wanted to find out is here's the plug. And I wanted to make sure that we weren't going to have any possibility of having AC on the chassis, which I didn't figure we would, and from the looks of it, we just have it just going straight to the coil here. Let's see here. Well, that. So let's see here. Hopefully they switch to the hot side. I would hope so. I find it very interesting they don't have a fuse in here either. So this is just filament voltage right here that goes to ground. We do have a center tap on the ground on the secondary. That's the ground, so really it doesn't look like we should be able to have a hot chassis. It looks like we're okay on that. You know, one thing I do need to check, the 6BH6 is the oscillator, 6AK6 is the buffer. I think this actually has two 6BH6s in it. Let me pull this out here. Let's go ahead and go back to our camera screen here. So this is a 6BH6. I just pulled out a moment ago. Let me put it back in. And I'm not totally familiar with these tubes specifically. They might be interchangeable. They're both 6BH6s. I'm going to assume this thing was working when it was taken out of use. So maybe those two tubes are kind of interchangeable. They basically have the same structure. But I don't know what, you know, the plate voltages could be different. That's one thing that I'm looking at here. So here's our voltage regulator. I guess you could say this almost act like a Zener diode. Coming up and feeding the plate on here. So this one looks like it's going to have a 150 volt plate voltage. Give or take, it does have a resistor right here. It's DC blocked over to there, so the signal's going there, but we still have, hopefully that one's good, or it's going to really make this tube unhappy. 150 volts on the grid probably wouldn't be a real good idea. This one either connects here through the inductor, and then, so I mean, that's basically straight off the rectifier and filtered. This is our filter, our power for the power. This is that big capacitor I was showing you. That's going to block the DC. So up through here, yeah, it looks like it could have, I'm going to guess somewhere around 300 volts on here. And as long as that one better be good too, otherwise we're gonna have 300 volts going out of DC going out of the coax. I think that one should be good. Yeah, I'm really hoping a 6AK6 can run 300, or 6BH6 can run a 300-ish volts on the plate. I guess we'll find out. Like I said, that's why it was in there when I opened it up, obviously. And I'm going to assume the thing worked before it was retired. So we're going to just kind of assume that a 6BH6 will replace a 6AK6 and work adequately. So I do have the dim bulb tester hooked up. Right here is the plug for the VFO. I just have one bulb in it. Don't think this thing's going to pull more than 20 watts or so. If this goes real bright, I'll probably shut it off. Put the other one in there and see what it does on too. I got a 40 watt bulb in there. Got the Variac. The dim bulb is plugged into the Variac right down here. And I do have the switch in current limit, and the power's off right now. So let's I'm going to turn this off. Got it in standby, so it should just be heater voltages being applied to it. It shouldn't actually be working at this point in time, but this is going to tell us if that one electrolytic is good. Do have the variac down on 0 volts right now, so I'm going to go ahead and turn it on. 0 volts. I'm going to turn on the power from the dim bulb tester. And I'm going to start bringing up the, I'm going to go ahead and put this in 80. So far so good, but we have 0 voltage basically going to it. So I'm going to start turning up the voltage a little bit. And we're just going to keep an eye on this bulb. If I get it up to about, put it about 50 volts. Let it set there a minute. You can see inside there. I don't think you can see it. You can just barely see the light right there, that little bit of green right there. So we do have, the filament is actually lighting because I believe that bulb's running off of the filament transformer. Nothing on the dim bulb. So I don't see anything so far going wrong anywhere. I'm not even sure the tubes are warming up yet. So it's sitting there at 51 volts and things seem to be so far so good. I'm going to go ahead and bring it up a little bit more. You see that bulb's getting a little brighter. It's about 74 volts. Nothing on the dim bulb, and our power indicator is getting brighter. So we probably don't have quite the 75, 73, 74 volts going through it. The dim bulb, it should be passing pretty much everything right now, but it might be closer to 70 volts. Go and crank it up a little bit higher. Come up to about 90 volts. Definitely got good good illumination on that light now. Nothing on the dim bulb. Just ever so little bit of glowing on the dim bulb. You probably can't see that. Just a little bit of red to it. That probably means the tubes are heating up right now. So it's starting to pull a little bit of current, and we're at 103 volts. Just going to let it sit there a moment. It's probably just down just a little bit from that. It's starting to get a little heat on that bulb. So it's pulling some current. But we definitely don't have any shorts so far. Actually looks like our dim bulb's kind of dimmed a little bit more. Probably the, yeah, I can see the filament in the rectifier lit up. I can't really see if there's anything on the other two tubes, and of course the it's probably not got enough voltage yet to activate the regulator. So let me bring this up a little bit more. Getting a little more glow out of the dim bulb. Can hear just a tiny little buzz from the transformer. Just kind of letting it sit there a minute, see if it's see to what it wants to do. Definitely got plenty of light coming off of the indicator lamp. Really, to tell you the truth, the only thing I'm really worried about is that electrolytic. Just trying to see that if there's any heat coming off of anything, mostly where that electrolytic is. And I'm just going to come up back, I'm just going to take it all the way up to about 117 volts. Got just a pretty nice red glow on the dim bulb. And I can see a filament glowing in, it's probably the oscillator tube. I can't really see if there's one in the buffer. It's the getter's in the way from my angle. So I don't think we're dropping a lot of voltage here. I'm just about tempted to go into bypass here and see what happens. Just kind of letting it sit there. If that electrolytic wants to do any reforming or anything. I still think that needs to be changed in the long run. I'm going to go ahead and go to bypass. So we have full 119 volts going to it right now. I'm going back to bypass. I'm hearing something. I'll go back to bypass. Yeah, I'm hearing something. I don't think I should hear anything out of this. in standby. And best thing to describe you to what I'm hearing, and it's just very faint, is it almost sounds like a vibration, or like when water just barely starts to boil and you get the tiny little bubbles. And what I'm concerned about is that it might be that capacitor starting to vent or something. And it does definitely go up when I go into bypass. I can't think of anything in this circuit that should make a noise when it's in standby. I can't, besides maybe some transformer hum. I can't think of anything in this in normal operating should make any noise. So I think what we're going to do is we're probably just going to stop on any further testing on this. I'm going to clean it up a little bit. It's got a lot of dust and stuff on it. And probably see if I can't get a replacement capacitor for that, and yeah, maybe figure out with that one big resistor in there that just looks like it's had better days. I don't know if it had like a coating on it that's come off, but it looks hairy. It almost looks like fiberglass is starting to break down. So I think that's something that next thing needs to be checked. But I just don't like the fact that I'm starting to hear something out of it. That could be it could be that capacitor beginning to really fail. So I think we'll have at least that capacitor replaced before we go any further with it. Like I said before, I cannot think of really anything at this point that I would use this VFO for, but I like old radio gear, and this qualifies. So even if it's something that basically gets put on display, or you never know, maybe I'll use it as some sort of frequency source, or some kind of signal generator type deal. It's not the cleanest output. Obviously, you got those harmonics. It's the basis of how it works. But definitely something to clean up, and I'd like to get it at least into working condition, even if I don't use it. It's just a cool thing to have. You can have nice things that sit on a shelf and look pretty, but if they work, that's more than just a piece of something sitting on a shelf. So I'll definitely see if I can get it to operate, and we'll probably have another video on there. I'll get another capacitor in there somewhere down the road. We'll revisit this and do some testing on it. Maybe look at the signal output on the oscope. See what kind of signal it puts out. How clean is that signal? What's the waveform look like? Stuff like that, and just kind of do a little bit of playing on it. But in the meantime, the Night VFO definitely needs some work. Trust me, this was a pull it out of a box and don't do anything to it and turn it on. And up to the point where it started making some weird noises, which I cannot think of any reason why it should. I think that's a good place to stop. I don't want something catastrophic, particularly going on with that capacitor, because if it shorts and it goes straight to ground, especially if I don't have the dim bulb in line, which is actually getting dimmer. So maybe it might be reforming that capacitor. I'm going to do this one more time. Hopefully I don't regret it. Yeah, it started making that noise again. And it didn't really sound like transformer buzz or anything like that. And we haven't really even loaded this thing down. Of course, that's actually brighter when I come back to current limit. So I think there's something going on with that capacitor. We'll get that replaced. And then we'll continue on. Like I said, wasn't working on anything else. Just thought, I want to take a look at this thing, see if it even turns on. It does. But I think that's about as far as we want to go with it right now. Do a little work on it, clean it up, get the cap changed, take a look at a couple other things, maybe check some resistors in there, see if they've changed in value. And we'll return in a later video and take a look at this a little bit closer. And like I said, see if we can put some signals, put some output out on it. I don't really want to say signals. But see if we can get it calibrated and make sure it's in good shape. So I'm just going to go ahead and turn down the variac. And switch everything off. And thank y'all for stopping by the radio room on a late evening and just taking a look at some old stuff that was sitting around, see what's going on with it. Like I said, thanks for stopping by, and bye for now.